Okay, so now we will tackle user VPN, which is basically remote access VPN to allow remote users to access the resources and the applications that are hosted in the public cloud. So now more than ever, I think with post-COVID, there are many companies who have who are running basically all remotely, and there is always some companies that are running hybrid mode. But regardless, there are users who are in different locations and they need access to the resources, apps and services that exist in this multi-cloud setup. We always want to achieve least latency, accessing the cloud resources. We don't want to backhaul to on-prem. There are many solutions and many deployments that rely on backhauling the traffic, meaning terminating the VPN on-prem and leveraging the whatever sort of private circuits or IPsec VPNs to take you from on-prem to the cloud. We want to have a solution that is for the cloud with the least latency. So I think it's essential nowadays that we provide identity provider integration, similar to what we have discussed with RBAC, so that you don't have to configure additional usernames and passwords on the controller. You rely on your existing IDP for authentication. And the solution that we provide, as everything we do, has to have the notion of multi-cloud repeatability, meaning that we can deploy it in multiple cloud service providers with a few differences. So we'll go through this at a high level, and then I'll take you to some lucid charts just to explain more in detail. So in a nutshell, we have our Aviatrix controller as always. You have a transit VPCs as well as some spoof VPCs that might contain the workloads that the users want to access. The remote users, we will classify them into profiles. You can think about profiles as groups. So you might have partners, you might have contractors, you might have HR versus IT versus finance. And the idea is to provide least privilege access for each of those profiles based on the resources that they require access to for doing their job. And this is the spoke gateway. I know it will become less clear once the load balancer comes in, but this is basically the spoke gateway in the VPN VPC. This is just like any other VPC, you need a spoke gateway. And then on top of that, treat this as a spoke gateway. Then what we do whenever we spin up the VPN setup, again, this will become more clear on the Lucid, is that the network load balancer, we will spin up in AWS a network load balancer for you that has behind it a pair of VPN gateways, okay? One or more VPN gateways to be specific. These are not spoke gateways. These are specifically specialized gateways that are meant to terminate the VPN connection coming from the users. Okay? So, and then the idea is once the users authenticate, we need to map them to the different profiles, which are, in the example are the partners, contractors, and employees. And based on who they are, we want to allow them access to either a full VPC or certain resources, let's say within the blue VPC for profile, for partners. For contractors, we give them the purple. For remote users, maybe, for employees, we give them access to both VPCs. So what I'm going to do now is, this is OpenVPN compliant. We also support the enterprise identity provider. This is by which the users can authenticate against an identity provider like Okta or Duo or Azure AD or any of those SAML-based IDPs. And what's interesting about the solution is once you are able to authenticate and you land on these VPN gateways, you are able to roam anywhere within the multi-cloud environment, obviously subject to the profiles and rules that for the resources you are allowed to access. But there is nothing preventing you to go to GCP and access resources, or to go to Azure and access resources. This is at a very high level how the solution works. I'll explain now all of these in more detail on Elucid. Just give me a second and I will share my yeah. I think you should see my Lucid for now. I will zoom in. I'll try to explain the setup in a nutshell. So you can see here, I have some workload VPCs. I sometimes make the font bigger just because I'm trying to make a point, but at the end of the day, these are some VPCs. This is the management VPC where the controller and the copilot lives. These are some workload VPCs. You can, I've called them dev, prod, whatever that is, but basically each VPC has a CIDR. They have spoke gateways in them, as we have discussed. And these spoke gateways will connect to the transit gateways. As always, transits are already peered. Now we are coming to the VPN setup, okay? So we have a couple of users or user groups who want to access the applications inside the different VPCs from their home locations. So the way it works is, basically, whenever you want to deploy a VPN, as I mentioned, you create a VPN VPC, if you want to think about it, and you put a spoke gateway. This spoke gateway is just like any other spoke gateway. It's like the spoke gateway inside the dev1 VPC. There is nothing different about the spoke gateway. It will attach to the transit gateways that are in the transit1 VPC. Now, when you deploy the VPN gateways, what happens generally in AWS is we will deploy a network load balancer. This is a network load balancer, an NLB, and put behind it one or more VPN gateways, depending on the number of users that you want to remote access VPN. Obviously, this becomes a sizing exercise, and we'll touch on a few aspects of it once we get to that point. But in a nutshell, you'll have the network load balancer, you'll have one or more VPN gateways, and then you will have a spoke gateway that connects to the transit. Okay. The next thing is that the user, now let me just explain the concepts of global accelerator and latency-based routing. These are two important concepts that the CSPs generally provide, like AWS. What's interesting about the Aviatrix user VPN solution is that with one click, you can automatically make use of these features. So I'll explain what are they used for and what is the benefit. Okay, let me get this out of the way for a second, and then it will become clearer. So assuming that you have a user, right? And let's assume that this setup is, I'll just try to draw things directly. So let's assume that this setup is in the US, and that this user here, the users are in Singapore, okay? So both of these users, the HR and finance users, are residing in Singapore, just to explain the idea. So if now the user wants to get to this load balancer, which is again hosted in the US, in order to establish the VPN, because the load balancer is gonna send the connection to one of these VPN gateways so that this VPN is actually set up. The problem is, how does this user get to this load balancer? If this is on top of the internet, let me check if I can find just any router for our discussion. So if this is on top of the internet, you will have probably tens of routers, and for this user to be able to get to the load balancer. Try to put a line. So what will happen is this user will go through this router, this router, this router, and this router, through this router, and then finally to be able to get to this load balancer, right? The problem with this might be a high latency path, and the quality of experience of this VPN connection might be affected. Okay, so what global accelerator is, okay, let's focus, what we're talking about now is global accelerator. So let me just change its color so that we all know what we're talking about. Global accelerator is all of these CSPs. So now you understand the problem. First, let me just remove it. Remove these routers from the path. What global accelerator is in a nutshell, these CSPs, all of them have, in AWS terms, we call them edge locations. Okay, so these edge locations generally are available across major cities in the world. So there will be probably edge locations in Singapore, edge locations in London, edge locations in, as I said, multitude of cities globally. So what's interesting is these edge locations are connected to the AWS network internally. So they have generally a much better latency, by which, let me just get the arrow here. They have a better latency, higher throughput. It's basically an internal network by which the edge locations connect to the rest of the global CSP network, and they can get to this network load balancer in AWS. Again, these edge locations are owned by, they're basically, you can think about them as an extension of the CSP network. So what is going to happen, instead of the user jumping over multitude of routers or various routers to get to the load balancer, the user is going to be pinned to a location, to a CSP location that is generally in the same city, or in our discussion is going to be Singapore. And then once you get to this location, you will ride the AWS network, in our example, to get to this network load balancer. So the end result is a much better experience and a lower latency for the user to get to the load balancer. And the way they do it is Anycast, they basically advertise a pair of IP addresses globally from their edge locations. And just because of how the nature of routing and how BGP works, each user, depending on their location, will be pinned to their closest location. So if I'm a user in Singapore, I get to the edge location in Singapore. If I'm in London, I get to the location in London. And again, the whole idea behind this is to improve the connection, to improve the quality of experience for this VPN connection. Okay, so this is called Global Accelerator. Again, this is a feature that is available within AWS. The interesting thing about Aviatrix is with one click, we can automate this functionality and get it, basically apply it for our user VPN case. The next feature now that I'll focus on, I'll remove Global Accelerator. And now we'll focus on latency-based routing. Sometimes it's called GeoVPN. So if you see these terms, GeoVPN or latency-based routing, we're talking about the same thing, GeoVPN. This is exactly, they both refer to the same thing. And it's important to understand that latency-based routing or GeoVPN only exists when we have two different setups. Okay, if you have a single setup, you will not have any this. I mean, there is no point. Latency-based routing or GeoVPN does not apply. So let me explain what GeoVPN is all about. Let me remove this edge location. I hope this was clear, the global accelerator portion. The GeoVPN is, so you have a setup in US and you have another setup, let's say, again, I'm just making this fictitious, in Japan, right? And the question becomes, is you have a user in Singapore. Where do you send this user to? Because what you want to give your users, your VPN users, a single VPN endpoint, which is in my example, in my lab was vpn.aviatrixninja.com, but it could be any endpoint. And this is purely DNS. So what we're doing is we're saying vpn.aviatrixninja.com, this maps to load balancer 1. Okay, let's assume that this is load balancer 1. Or better, I'll just write it here somewhere. So this is going to be LB1, or it maps to load balancer 2. Okay, so again, this is purely a DNS play. So you either say it maps to load balancer 1 or load balancer 2. What's nice about this deployment is anyone globally can use the same endpoint to connect, which is vpn.aviatrixninja.com. The question becomes is, where do you send the user to? If a user is in Singapore, do you send him to load balancer 1? Or do you send him to load balancer 2, which is basically, do you send him to the US setup or the Japan setup? The way it works is the CSPs, AWS in particular, which is, I mean, what we call the feature GeoVPN, other CSPs will have different implementations. AWS maintains a database by which they collect latency data. They say if a user is in, let's say, Singapore, and the latency between Singapore and US is this, and the latency between Singapore and Japan is this. It's important to note that this is not live data. However, it is still useful, I mean, as an alternative to not having any other means of doing it. And in order to figure out where the user is from, we are relying on the geo IP information of the user, which might or might not be accurate. So if the user now is in Singapore, I'll explain it one more time. What we're going to do is we are going to compare the latency. If I can draw, we're trying to compare the latency of the path between the user and the load balancer here versus the latency of the path. Again, I mentioned this is not live. This is just based on historical data that CSPs maintain to this setup. So what we're basically saying is AWS will look at its database, say, from Singapore to US, let's say, and from Singapore to Japan. And I mean, let's assume that we are going to pin this user to Japan. What's nice, again, about the solution is if this user were to go and roam around and travel maybe to the US, he will use the same exact setup and might this time be pinned to the US. And the idea is if you create multiple setups globally, you will always ensure that users are pinned to their nearest location. Okay, so this is global accelerator and latency-based routing, or GeoVPN in a nutshell. Again, worth noting that GeoVPN discussions only come into play whenever you have more than one setup for the VPN. If you have a single setup, then there is no discussion about GeoVPN. Okay, the third point I want to discuss now that we have cleared both of these is, so we already agreed that there is a network load balancer that gets spinned up, and this network load balancer will have behind it the VPN gateways, and there is a spoke gate. So once the user connects, let's assume the user connects to the setup in the US, The first thing that's going to happen is this user is going to get an IP address. And this IP address is the IP address for this user to communicate on this remote network from their perspective. And if you've ever done VPN, you will realize that if you're on Windows, you will see another VPN adapter with an IP address. Now, what's important to note is this IP address is based on a CIDR range that you will have to configure on these gateways. So if I configure 192.168.43.24, I will have to configure this on the gateway. And now any user who connects and gets pinned to this gateway will get an IP address from the 192.168.43 range. Obviously, if I have the other gateway, should have a different range. The reason this is important is you don't want to have overlapping addresses on your network. So I'm having 43 on the first gateway, 44 on the second gateway, and finally, 45 on the third gateway. Okay. Again, this is very important, and you should always use IP addresses that are not used within your environment to make things much easier. Okay, so this, if you go to the controller, let me try to show it to you, and you go under a gateway. Yeah, I don't have a VPN gateway, but if we have a VPN gateway here, we will be able to, there'll be an option basically to decide on the VPN CIDR range for that gateway. Okay, so you will find it under the gateway edit, and there is an option I'll show you now in the slides where you can basically decide the IP address. Okay, so we were looking here. So now the other problem that arises is, okay, so you're giving the users IP addresses. So if a user joins, he connects, he gets an IP 192.168.43.10. The problem becomes is how does this spoke gateway or even this transit, so the packet goes through the spoke to the transit to the spoke, but now the return traffic has to go to 192.168.43. But all of these gateways or the fabric does not actually know about 43 or 44. They only know about the CIDR range of the VPC, which is 10.110.0.0/16. So again, the problem is that you are providing a new subnet to these remote users, a new CIDR range that your fabric does not know about. There are two ways to solve the problem. One way is to configure source NAT on these gateways so that when the traffic goes through them, they will change the IP addresses of 43, for example, on the first gateway, or 44. They will change them to a source NAT, meaning they will change it to its own, to the gateway's own private address, which lives in the 10.110 range. This will solve the problem, because now when the packet goes to the transit, the source address is not 192.168.43, but the source address is 10.110.0. something, which is the IP addresses of the gateway here, or even the gateway on the right. Okay. However, the downside of doing this is that if you have 100 users or 200 users, all of them will show up as a single IP address or two IP addresses in the case of two gateways, which means if you have a security incident or you're trying to look at logs, you will only see the IP addresses of these two gateways, and it will be hard for you to figure out which of these users who connected remotely actually had the problem or was a source of a malicious activity. Okay, so in order to maintain end-to-end visibility, we prefer not to have to do source NAT. The other option becomes is we can go to this gateway and tell it, hey, you know what? You are already advertising 10.110 into the fabric, right? So the gateway today, let me just fix it so that it becomes, without doing anything, the gateway is advertising 10.110, which is the CIDR range of the VPC, into the transit and into the fabric. We ask the gateway, in addition to this, please advertise for us 192.168.43.0 and 192.168.44.0. So this way, all the fabric knows about not only this CIDR, but also these two additional CIDRs. And this way, we don't need to NAT, because even if the traffic goes through with the 192.168.43, all the fabric knows about 192.168.43 and is able to return the traffic back to the user. This functionality, if you go to Copilot and you go to gateways, spoke gateways, for example, I can click on any of these and look at settings and look at routing. There is an option which is customize the spoke advertised CIDRs. So we are customizing what this spoke is actually sending to the fabric. It's important to understand that this overrides the natural behavior, meaning that if I go back to my diagram, if I only put 192.168.43 and 44, this will override the 10.110. So it's important to keep putting the 10.110 as well as in addition to the 43 and 44 CIDR ranges. Okay, so we talked about, again, how we're going to get end-to-end connectivity. One option was the NAT option, which is not very recommended because it hides or masquerades the original IPs of the user. The second option, which was more recommended, whereby we tell the spoke, in addition to advertising your CIDR range, please go ahead and advertise the two other CIDR ranges for the VPN. Another concept I would like to touch upon is the concept of split tunneling. So split tunneling is, I'll probably start with full tunneling and then probably split tunneling will become easier. So if you don't do any split tunneling, or if you are doing full tunneling, it means, in a nutshell, what you're doing is that this user's default gateway will actually be the VPN. So what we're doing is the default gateway of this user, let me just make this one, okay, will point to the VPN. Which means that even if this user goes to, if he wants to go to the internet, that internet will actually go through the VPN gateways. Whatever the user is doing, even if the user has certain resources on their network that they had access to, they will lose this access because all the traffic is being pinned to the VPN setup. This is called full tunneling, because in an, just try to put it here. This is called full tunneling. Okay, so this is full tunneling because we are sending all the traffic on the tunnel. Again, this might not be, I mean, there are certain organizations who prefer it from a security standpoint, but this might not be very feasible for all deployments. And there are organizations who make use of what is called split tunneling. So split tunneling is, instead of sending all the traffic to the VPN, you will go and say, hey, I only need access maybe to 10.1, 10.2, and 10.3. So maybe you can go and say anything that is 10/8 goes to the VPN. Everything else continues to go on the user's local network. So your default gateway remains on your modem, for example. If you're at home, you can still access your network, your printers, whatever you have. It's only you are only tunneling whenever the basically the destination is within the 10/8. Any other destination that you want to reach will be you will try to reach it over your private, basically over your own network. What this means is your default gateway is on your, I don't know, could be your on your Ethernet or whatever wireless interface that you are connecting to. Okay, so this mode is called split tunneling, and I think the reason is obvious that you have two legs, right? One leg that sends partially some of the traffic to the VPN, and the other leg that sends traffic over the local network. Okay, so this was, again, another concept where we explained split versus full tunneling. Now, a few words on profiles and authentication, and then we can go back to the slides. So the preferred, I mean, you can do authentication on the controller. This actually works, but is not very scalable. Generally, if you are a large enterprise and you already have an IDP like Okta, you would probably want to leverage that and integrate it with your user VPN solution. And this is, I think, I mean, this is the recommendation for any enterprise-grade deployment. So the way it works, the thing that I want to explain is there is a concept of a profile. It's very important. The profile here is denoted by the HR or finance or IT or contractor. This explains the user's role within the environment, and this allows or prevents access from certain areas. So let's say you are in HR, so maybe you want to access the HR servers. So I will only provide you access to those HR servers, and everything else will be blocked from you. The way you can think about it is like it's an identity-based firewall rule that is done based on which profile you belong to. So the way it works, again, is, so let me just explain what a profile is first. So a profile is nothing but a way to group. It's like a group. You can think about a profile like a group, and you will have an HR group, you can have an IT group, you can have a finance group, regardless. And whenever you define these profiles, you define a firewall rule. Let's say allow 10.0.0/8. This is all what you define in a profile. And if you're doing an allow model, sorry, if I can type 10.0.0/8, and inside this profile, maybe you say everything else is denied. Okay, so this HR group is only allowed to get to 10.0.0/8. Okay, and now the question becomes, how do I know that this user who joined is part of that profile? If you're doing it via the controller, which is again not the recommended way, you can manually assign users to profiles. It's very important to assign to profiles, because profiles, if you don't have profiles, then you do not have access. Profiles are what allow you to have access. You can even have a profile that is like a super user, which allows access to everything, but you always need a profile. So if you're doing on the controller, you are able to manually map a profile to a user. If you're doing it via Okta, remember the permission group discussion that we had in authentication. What's going to happen is Okta is going to authenticate the user. And once the user is authenticated, Okta will know which group and which profile the user belongs to. And then it will have to tell the controller, it will have to share this information. If I see here the controller, if I put Okta here just to make things easier, Okta after post authentication will have to go and tell the controller, sorry, my bad. It will have to return back to the controller and say, this user, for example, Simon, belongs to profile IT. Okay, now the controller already programmed, already has inside it configured what the profile IT can access. So if you remember the HR, let me make this HR, because we already defined that HR can access 10/8. So what the controller is going to do is going to go to these VPN gateways, or basically the VPN gateway where the connection got terminated, because it could be either the VPN gateway on the left or on the right. It will go to that specific gateway and push the firewall rule that allows Simon to only access the 10/8. What's interesting is all of this happens automatically. You are not managing the rules, and when Simon disconnects, all of these rules will also be removed from the gateway. Okay, again, this is the most recommended way of deploying the setup. Okay, I think this was hopefully a good overview on user VPN. Now I'll go back to the slides to check if there is any concepts that we have missed. Okay. So I think this is now very clear. We talked about the VPN gateways. There is a different spoke gateway. We talked about GeoVPN or latency-based routing and user accelerator, which is AWS's global accelerator. And we talked about the enterprise identity provider and how we can authenticate with the SAML-based IDP providers. In terms of client softwares, you can have two types of clients. You can either have the OpenVPN client, the advantage of which is it is available on more operating systems, or you can have the Aviatrix VPN client. It has its support on macOS, Windows, Linux, and BSD, Linux Debian to be specific. The advantage of the Aviatrix VPN client is it can do SAML-based authentication. So if you are looking at integration with Okta or any other IDP, then you should use the Aviatrix VPN client. As we discussed, we automatically launch a load balancer for you, so you don't need to know about this, but all of this happens for you. This is showing in AWS that the load balancer has been provisioned for you, and it has basically targets. The targets of the load balancer are our VPN gateways. They are the targets of the network load balancer. We will automatically attach the VPN gateways to the load balancer. You can either use the default domain name of the load balancer, or if you have a custom domain name, like I showed you, Aviatrix Ninja, vpn.aviatrixninja.com, you can also use that. I've also explained the logic of a profile. The profile is meant to provide each user their required level of access based on the group they belong to. Again, we discussed is when the user authenticates, specifically with Okta, Okta will figure out the group. It will tell the controller will push the relevant rules to the VPN gateways that are behind the load balancer. And this is how we will ensure that the employee is able to access certain resources, whereas the contractor is able to access other resources. All of this happens dynamically. You don't need to be aware of any of the rules. When a user connects, the rules will be imposed. When a user disconnects, the rules will be deleted. So we already talked about the support for the IDPs. And again, in my opinion, this is like the best way to deploy, especially if you are a large enterprise. We talked about profiles, and what profiles are in a nutshell is you're basically configuring a firewall rule. And so in this firewall rule, for example, you're only allowing that specific profile, which is interns, to access 10.150.17.0, and everything else will be denied. Okay, which means interns will only have access to this specific prefix. If you wanted to limit it to a specific port, that is also possible. Note that this rule is only there in the controller. It will not be applied unless we have a user from that profile that tries to connect to the VPN. Okay, I just wanted to clear these rules are not being pushed unless we have users that belong to that profile. So a profile can be associated with multiple users. That is very logical. So if you have a user like, if you have a group of HR, you generally would expect that you will have multiple employees from the HR department or from the IT department. So it's very logical that the group will have multiple users within it. Maybe less logical, but also possible. The user can be associated with multiple profiles. So if a user is associated, let's say, with IT and with finance, he will get the union of both. He will get the union of both privileges. This is, again, not very common, but possible within the solution. And what we were seeing here. So you can, as I said, if you're doing it on the controller, you will need to attach the user to the profile manually. Okay. Again, I would say not very scalable. If you have an IDP, you can make that via SAML. We already discussed GeoVPN. So what GeoVPN is latency-based routing, and it's basically, if you have a user, it's only, first of all, it only comes into play whenever you have two different setups. So here we have a setup in AWS that is in US West 2, a setup in AWS that is in EU Central 1, and you have a VPN user. You give them a single VPN, a single configuration file, which is basically a single endpoint. And the question becomes, do you send them to this load balancer? Basically, do you send them to US West 2 or do you send them to EU Central 1? And the idea is, again, the latency from the user location, which is based on GeoIP, to each of these load balancers is measured. And the one with the lowest latency is where the user will be pinned to. So this is the coming to the VPN CIDR block. What we discussed is whenever you have a VPN, the VPN gateways need to be like a DHCP server, serving addresses for these remote users to be able to communicate on this network. So you will need to provide a VPN CIDR block. And as we mentioned, if you have the multiple gateways, it's very important that you have different CIDR blocks, as you don't want to have overlapping addresses on your network. So again, there is the concept of client certificate sharing. I'll explain it in a very quick terms. By default, if you're doing authentication via the controller, then each user needs to have his or her own certificate, as this is the way we are authenticating the user. So again, this is not very scalable. If you're doing authentication with the controller, I need to distinguish that this is Simon versus this is Julie versus this is David. So what I do is each of these users will have his or her own cert, and whenever they authenticate, they will present their certificate, and this is how we know, this is how we can authenticate them, and this is how we can map them to certain profiles. However, again, this is not very scalable, because if you have 200 users, then you have 200 certificates, and the issue is not only about issuing the first certificate, but also about rotating these certificates and making sure you don't have to deal with expired certs. Thus, the better model is, especially when you have an IDP, this is always also another reason why I recommend the IDP, because it allows you to do what is called client certificate sharing, which means all of the users will actually have a single certificate. The reason we can do this is because authentication is happening via the IDP. So the authentication has a different route. It's already relying on the IDP, different usernames and passwords. Thus, you can all of the organization can share a common client certificate, which makes the solution more scalable and less and much easier to maintain. Okay. The controller can see the individual users, and the reason they can do, because it's the IDP will send back the information that it was Julie or Mike that actually tried to connect. Okay, so for most intents and purposes, for an enterprise grade deployment, you will have client certificate sharing enabled. If you're running a very small setup or a POC, or you don't have an IDP, then you can have it turned off and leverage client certificates for each of those users. So we talked about the problem with about basically how is the fabric going to know about these 192.168.43 or 44? And we had two options. One of them is to do NATing on the VPN gateways, which means we are hiding the 43, we are hiding the 44, and we are only getting a single IP, which is the IP address of the gateway. This is a solution that works. However, as discussed, this contradicts the logic of end-to-end visibility. And I mean, you will lose a lot of functionality, especially on the logging, monitoring, and visibility front. The other option, which is better, is to go to that Spoke Gateway, as I showed you, and say, I want to, hey, Spoke Gateway, please advertise on top of the VPC CIDR range, please advertise the other two VPN CIDRs, so that the world or the fabric knows about them. And this way, we don't have to NAT. What we're showing here is the we do have a functionality whereby we can enforce the Aviatrix VPN client version to ensure that very old, if you have a very old client, generally we do it especially for security purposes. There might be some security vulnerabilities or that are found in very old software. So you can enforce a minimum client version for these users to be able to connect. If the users do not meet those, then they only have to upgrade their client, and they will be able to basically connect to your setup. We also have the capability of allowing or disabling duplicate connections. The idea is, if you have a user that has an iPad and that has a Windows machine, do you want them to be able to connect from more than one endpoint or from more than one device at a time? And this is what duplicate connections is all about. Once enabled, the user can connect from the iPad and the Windows machine. If disabled, the user can only connect from one of these devices. So we also talked about split tunneling versus full tunneling. So full tunneling, as we discussed, all the users' IP sessions go through the VPN tunnel. I also alluded to the fact that the way it works is there is a default route that gets programmed on the OS of the user that says, hey, if you want to go default, you have to go to the tunnel. And the way we can program the OS is because we have the VPN client. So the VPN client is taking the instructions from the VPN server, which is basically the VPN setup, and the client is programming the OS as routing table based on what we have configured, split or full tunneling. Split tunneling is about deciding which ranges you want to tunnel for, and the other ranges that you've not specified, everything else will be basically going through your local network. This is an interesting screenshot because it shows that, first of all, there is a tunnel interface. This is on a Mac, so similar thing you'll find on the Windows, but if you see the tunnel, there's a tunnel interface called UTUN5 on the Mac, and it has an IP address of 192.168.44. It has a gateway of 44.5. And if you look at the routing table of the host, you will see that the default route, okay, points to the local network, which is Ethernet 0. However, the 10.0.10, which is what we have specified in the CIDRs here, and 10.0.20, they point to the 44.5, which is the gateway over the tunnel. So this is how split tunneling implements itself, by manipulating the routing table of the host. As I said, only the destinations that you have specified will point to the VPN tunnel. Everything else, which is the default, will continue to point to your local network. In the case of full tunneling, the default itself will point to the VPN gateway. This is another interesting test regarding gateway failover, because if you remember, we have generally in most implementations, there's the load balancer and it has two gateways behind it. So what we're doing here is we are showing the tunnel 4 interface IP address. So the user's IP was 43.14. The gateway was 43.13. And we were able to ping a destination that is in the cloud. And then what we do is we shut down this VPN gateway. So you will lose a few request timeouts, and then the ping continues to work. And this happens seamlessly. You don't need to change any certificates. You don't need to intervene. It's just because the load balancer realizes that the gateway behind me is dead, so I'm going to shift the user to the other gateway. However, one thing to take note of is when you look at the IP address of tunnel 4, this time it has an IP address of 44, whereas before it had the 43. The reason this happened is now you are pinned to another VPN gateway, and that VPN gateway has a different CIDR range to provide to the users. But the interesting thing is that, this happens seamlessly. So if any of the VPN gateways were to fail, you are able to connect to the other gateway seamlessly. So this is the general architecture as discussed. You'll have a network load balancer that has behind it the two VPN gateways. This is where we're discussing the failure. So if one of the gateways fails, you have the other gateway. You have a pair or more of spoke gateways that will connect to the transit. Again, these are specialized VPN gateways. They cannot be spoke gateways. We talked about the idea of, the importance of authentication with an IDP. We're showing Okta here, but this could be any SAML-based IDP. We explained the logic of the profile, whereby we want to, after the authentication, the IDP will figure out the group or the profile the user belongs to, and it will inform the controller. This is how the controller will inform will push the rules to that relevant gateway, so that Mike, being a tester, can access certain maybe test instances, whereas Julie, being a developer, can access the dev instances. So this is again explaining some users and profiles. So here they're assuming that everything is being done on the controller. So you have a user that is called Mike Tester. He is associated with a profile that is called Tester Profile that allows access to 10.3. So once the user VPN client, again, because we don't have an IDP, we have to have a certificate per user. So Mike has a Mike.ovpn file, which is the client certificate that is issued to Mike to authenticate. And once he authenticates with the controller, then what's going to happen? The controller knows that this is Mike. We know that he has this profile. The controller will push the relevant rules to the relevant gateway where the VPN got terminated, and Mike will only get access to 10.3. This is a bit of an improvement, in my opinion, especially in terms of scale, where we put the users now in the IDP. However, the profile association is in the controller, which again is not something I would prefer, but this is a possible model. So we're trying to show you everything possible here. So we have notice the first thing is now we are using a shared certificate, right, for the user. So now notice that the users have a shared OVPN file. There is no need now to have a certificate per user. However, the authentication is being offloaded to the IDP. This is why we can use a shared certificate, and this is why it can scale better. So once we authenticate with the IDP, we can have, it could be Julie or it could be James. So assuming that it's Julie, let's assume for our case, we will send the information that, hey, the user is Julie. So the controller has already mapped manually Julie to a profile, which is a dev profile. And obviously the rule will get instantiated on the gateway, and we will only get access to 10.1 and 10.2. So the benefit here is we are offloading authentication to IDP, which means we can use the shared certificate. The downside is we are only sending the user information to the controller, so the controller is still the one that associates the user to one of these profiles manually, which makes it a bit, it's not very scalable in this deployment. The best deployment, at least in my opinion, is where to do the users are in the IDP, but also the profile association. Notice that it's not only the user, it's the profile association that also is done in the IDP. So you can say like Mike Tester belongs to profile tester, or user John Prod belongs to multiple profiles, prod, tester, and dev. Again, we use the shared certificate. So all of this is happening inside the IDP. So when we send back to the controller, we not only send the user, we send the profile association. So we're saying, hey, this is John Prod. He belongs to all of these profiles, prod, tester, and dev. So what the controller is going to realize is that we need all of these together, prod, tester, and dev. And this way, he will get the union of all of these 10.1, 10.2, 10.3, and 10.0. Okay, a bit on architecture guidelines. I'll put also this link as a reference. So one thing just to realize is, especially whenever you're trying to size how many clients do you want. So you can go and look at, this is the throughput of a VPN gateway. Again, let's assume 200 megs is the throughput of a VPN gateway. And you want to give per client 10 megs over this remote access VPN connection. This would yield to 20 clients per VPN gateway. Again, these are very rough numbers, and you can go into a bit more, I would say, thorough sizing exercises. Again, some of the things that are important is if where the user location is, are you using GeoVPN, Even are using split or full tunneling affects the performance a lot, because again, this is a huge one, I would say, because if you're sending all the traffic to the VPN gateway, this would mean that your VPN gateway has to be probably larger versus if you are doing split tunneling. As we discussed, the VPN gateway is a specific gateway. It's not a spook gateway. The traffic between the VPN gateway and the spook gateway is routed in the underlay. Again, this is the beauty of the platform, whereby the controller programs all of the underlay routing to make sure this end-to-end connection works. In terms of visibility and troubleshooting, I mean, these are some things that have existed in the controller and have not migrated to the Copilot. So you can see how many VPN users, obviously, in the last 24 hours. You are able to search and figure out who the user is, which profiles they belong to, what was their IP, what was their public IP platform. You can disconnect them. You can see how many times they connected and disconnected. And you're able to see what are the resources they try to access. So here we are zooming in on a VPN user that has a 44.6 IP address, and you're able to see what are the destinations and what are the protocols that basically they have used when they connected. You can always do a packet capture, which is really great if you are troubleshooting, and you can get the PCAPs and have a thorough look at why something, for example, is not actually working. So this is everything about user VPN. We will next go through Threat IQ and Threat Guard.